or write some more trigonometric identities. So these three are advanced trigonometric functions. Then we have this identity and this identity, which you must have learned in your first year of A levels. Of if you are in ad maths, you can be new to these. So if you remember this identity, from this identity we can derive cot x is cos x over sin x. And then moving on to this identity. So this identity essentially remains the same, and this is what you should remember. But this can be this can be embedded in alternative forms or can be called out in alternative forms. Like you can replace this whole thing with sin square x, or you can also remember this as cos square x 1 minus sin square. But this is the general form I'd say, and this is what you should remember. Then moving on, we have cos square x is equals to 1 plus cot square x. This is what you should remember too, and this too is the general form which you should remember. So these three are the general forms which you should remember, and these can be written in alternative forms. Like I can write this one as cot square x, this as the subject, and cos sec square x minus 1. Then I can also make, or I can take one to one side and the other things to the other side and write this as this. And then I have this. I can write this in alternative forms too, like for example this, or sec square x minus tan square x, everything to one side like this. But I'd advise that you remember this and this. And these are the essential concepts which you should already remember. And then how it is used. So we learned that identities can either be used in an identity to prove an identity or can be called out in a question. So let's look into how they can be used to prove these identities. So I can write this down as 1 over sine square x, and I can write down cot x as this. So cot square x is same as cos square x over sine square x. Since both of these have the same denominator, I have 1 minus cos square x in the numerator, and this is how it looks when written as a single fraction. Then this thing can be written as sine square x over sine square x. Both of these cancel out and I'm left with 1. And so on. Similarly, I have this. So I can write down secant square x as 1 over cos square x and tan square x as sine square x over cos square x. Using the identity of tan x is equals to sine x over cos x. Then we have the same denominator. Thus, I have 1 minus sine square x over cos square x. When written as a single fraction, I can replace this thing by cos square x, and thus I have cos square x over cos square x. The numerator cancels out in the denominator, and I am left with 1. Thus, I can write this during practice, and so. Ta-da!